So we're going to continue on with the review today, covering questions that we did not cover from the Exam 1 review problems. So that's that single sheet. So we're going to start in the conversion section, number 5 at the very bottom. So that's what I have written on the board here, 525 milligrams to nanograms. So when you're approaching conversion problems, your first step is to figure out whether it's English to metric or metric to metric. So to figure that out, metric to metric always has a letter in common in the units. So looking at this problem here, we'll notice that we have milligrams and then nanograms. So it has a G in common. So that tells me it must be metric to metric. So that helps me figure out where I'm looking for my conversion factors. So for metric to metric, you have this sheet posted on Blackboard in the week 2 folder when we did conversions, when we first did those. So you'll want to use this sheet to help you find the conversion factors. So when you're trying to find what conversion factors are going to work, you're going to look at the prefixes, so the first letter. So milli, little m, and then nano. Okay, so we know we're going to need 2 conversion factors because we have 2 prefixes. Okay, so I'm going to look up milli first, and I go down to the milli, the little m, and it's 10 to the negative third. If I look in the gram area, it gives me a conversion factor of 1 milligram is equal to 10 to the negative third grams. So that's one conversion factor that's going to get me from milligrams to grams. Okay, but since I have a second prefix, nano, I'm going to need a second conversion factor. Okay, so I'm going to look up nano now, the nano prefix on this table. I get down to the nano, and it's 10 to the negative 9th. So that means that 1 nanogram is equal to 10 to the negative 9th grams. So this second conversion factor here is going to get me from grams to nanograms, which is where I want to be. So it is 2 steps. So once I have the conversion factors I need, I can go ahead and start my railroad tracks. So starting them, they always start with the original number in the question, the number we're asked to convert. So 525 milligrams. Okay, we're going to use this first conversion factor to get rid of the milligrams. So I'm going to want to take the milligram portion, the 1 mg, and put it on the bottom so that they are on opposite sides of this horizontal line. That'll put my 10 to the negative third along the top. The milligrams are going to cancel out, and now I'm left with grams. But I'm going to keep going, so I'm not going to solve and stop there because I don't want grams. I want to keep going to nanograms. Okay, so that's where this second conversion factor, we're going to plug in here to get rid of the grams, and then once I have it all written out, then I'll calculate. So using this conversion factor, I'm going to take the gram portion this time, so the 10 to the negative 9th, and put that on the bottom. Because, once again, we need those units on opposite sides of the horizontal line to cancel. That'll put my 1 nanogram portion on the top. So notice all units have canceled except for the nanograms, and that's what we want. Okay, so now we calculate. Remember, we multiply across and divide by what's on the bottom. So we have 525 times 10 to the negative third times 1. We're going to divide that by 1 times 10 to the negative 9th. So you can enter those into your calculator just to make sure that you feel comfortable with using scientific notation, that EE button. Divide that by 1, so EE. 5, 6. So you'll get, depending on how your calculator is set up, you might get one of 2 answers. They're both the same, it's just one's in scientific notation and the other is not. So here's the normal notation answer. Remember, that's in nanograms. The scientific notation Remember, you want just one non-zero number to the left of the decimal. And the exponent's how many times we have to move it to get it there. So 1, 2, 3, 4, 5, 6, 7, 8. Both answers are correct, just one's in normal and one's in scientific. On the exam, it will be mostly multiple choice, and it'll tell you what it wants the answer in. So you'll be able to figure that out at that point. All right, let's try the next one. So flipping the page over to the next conversion problem. Okay, so we have this one, 740 millimeters is equal to, oops, it's not millimeters, mm. How many inches? Marker there to start here. That works good. All right, so first step, what type is it? English to metric or metric to metric? Looking at this, I don't have a letter in common. Millimeters, inches, IN. So it's not metric to metric. That doesn't mean that I'm not going to use metric to metric at all. It just means that I'm going to have to find at least one English to metric conversion. So it just helps me, shows me where to look. Okay, so we want to look at the conversion factor list, the English to metric conversion factor list. And when I look at that, I'm going to look in the length area because meters, millimeters, and inches are both lengths. So when I look in the length area, I have one option, just one, with inches in it. And that is 2.54 centimeters is equal to 1 inch. Okay, now notice this is going from centimeters to inches. And we're trying to go from millimeters to inches. Okay, so it's going to be another two-step problem, two-conversion problem. Okay, so this one, I'm going to write my plan, will get me from centimeters to inches. Okay, but I'm starting at millimeters, so I need a way to get from millimeters to centimeters. So let's write that out. If I want to get from millimeters to centimeters, so just looking at this section, what type of conversion is this? Well, looking at it, letter in common, we got the m's in common. So since we have that letter in common, we know it's metric to metric. Okay, so we can look at this sheet and find some conversion factors, or there's a shortcut way that I showed last week. And the shortcut way is using this prefix table. So King Henry died drinking chocolate milk. Okay, so this only works for metric to metric, and it only works from kilo down to milli. Okay, so the reason we didn't use it on the last problem, because remember the last conversion we just did was a metric to metric conversion. So why didn't we use this? Because the last problem went to nanograms. Okay, this goes from kilo to milli. Nanograms is way down here. Okay, so it only works for a small subsection of prefixes. So if you have metric to metric somewhere between kilo and milli, you can use this, and this will allow you to just move the decimal. So no conversions necessary, no crossing out units, simply just moving the decimal. Okay, so it's a shortcut way. So let's look at how we're going to use this. Well, checking our units over here, so millimeters to centimeters, let's make sure it falls in the range to use that method. So I have millimeters, that's this guy down here, and I have centimeters. So yes, it'll work. Okay, so how do I use it? Well, what this is going to do is it's going to tell me how many times to move the decimal, and it's also going to tell me what direction. Okay, so how does it do that? Well, I'm starting at millimeters, right? That's our first, 740 millimeters. That's where I'm starting, at the end. I want to go to centimeters, so I want to get to the C. So how do I do that? I'm going to have to move the decimal one time, because they're right next to each other, What direction did I just go? To the left. So I'm going to go over here. I'm going to start at the decimal point, and I'm going to move it one time to the left. Looking at this number, there is no decimal point present. However, if there's no decimal, you just start at the end of the number. Okay? So I'm starting at the end of the number, and I'm moving one time to the left. So my 740 millimeters, once I move that decimal to get it in centimeters, I now have 74 centimeters. So I have completed this first step. I am now at centimeters. So at this point, I can use my English to metric conversion factor with my railroad track method. I'm starting with the centimeter version of the number because I need to cancel out centimeters. So I'm going to put my 2.54 centimeters on the bottom, opposite sides of the horizontal line, my 1 inch on the top. So when I calculate this out, for those of you who like it written out, write it out quick. Basically taking 74 and dividing it by 2.54. I get 29.1338. Okay, I don't want all those numbers. I want to know how many sig figs that I need to actually use. So I go back up to my original number that we started with, count the sig figs, and then represent that in my answer. So looking up here, my 7 and my 4 count. Does this 0 count? It does not, okay, because there is no decimal point. So there's just 2 sig figs. Go down here, starting counting left to right, 1, 2, look at the number next to it. That's going to stay at 29. And then last but not least, include your units. It is 29 inches. Right. So let's look at the next one. So moving on to number 6. So number 6 is just a calculation problem. It's an addition and subtraction problem. So the reason I put in a problem like this is because most of the conversions that we're doing, we're dealing with multiplication and division. And the rules for multiplication and division are to count the significant figures as a whole and then pick the smallest one. So we kind of get into that habit, and then we forget that the rules change when we're adding and subtracting. So when we add and subtract, we're not looking at sig figs as a whole, we're looking at decimal places. But we are still picking the smallest. All right, so let's look at this problem. So we're adding and subtracting, so we're not counting total sig figs anymore. That's only for multiplication and division. Instead, we're going to look at just after the decimal. So I'm going to look at every number that is in the problem, and I'm going to count how many decimal places each number has. So for this first one, after the decimal, I have 2. I'm writing DP for decimal places. The next one, looking after the decimal, I have 3. Notice I counted this 0 here. It's not a significant figure because we can't start counting until we get to our first non-zero number, but we're not looking at sig figs with addition and subtraction. We're looking at decimal places, and this counts as a decimal place. This is the 10th spot, right? So we do have 3 decimal places here. So for this next one, we're going to have 6. So those 2 zeros count as a decimal place. They don't count as a significant figure, but they do count as a decimal place. Okay, so now looking at these numbers, pick the smallest, 2 decimal places. So what that means is once I calculate this answer, I want to make sure that I go out 2 decimal places. 2, 3, 4, 5. 0.686655. Sloppy, ready? So when I did this calculation, this is what my calculator spit out, but I need to look at my counting and figure out how many digits I want to represent. We just said 2 decimal places, so start at the decimal point, count 2 spaces, always look at the number next to it. Is that going to stay at 8 or round up? In this case, it's going to round up, so we get 3.69. So notice our answer, if we're counting sig figs now, so now I'm going to sig figs, not decimal places. We're counting significant figures, there's a total of 3 significant figures. 2 decimal places, but 3 significant figures. So note that difference. All right, so now let's look at a rounding problem. So number 7 is asking us to take the number 156 and round to 2 significant figures. Okay, so we've done a few like this, but this is a review, so we're going to do another one. So remember, when you're counting sig figs, you always go from left to right. So I start counting at the 1, so that's going to be my first sig fig. The 5 will be my second. Look to the number next to it. In this case, does that stay a 5 or round up? And it does round up, so we're going to get 1/6. But we don't want to just put 16 and stop there. It's correct to the point that we do need a 1 and a 6 in our answer. It's correct to the point that we need 2 significant figures in our answer. However, notice we went from 100 and something down to 16. So the order of magnitude is not the same. So in order to make it 100 and something, we need to add another digit here. And we need to add a digit that will not be significant so that we can keep it at 2 significant figures. So the only number that is sometimes not a significant figure is going to be 0. So 160 would be the correct way to round that number to 2 significant figures. Okay, next we're going to do a division problem. So this is just practice with counting significant figures. So if we have 0.2150, we divide it by 0.0060. Okay, so now we're doing division. And with multiplication and division, we count sig figs as a whole. Right? Addition and subtraction, decimal places. Multiplication and division, sig figs as a whole. So let's go ahead and count. Top number, 1, 2, 3, does that 0 count? It does because of the decimal, and we already started counting. Looking in the bottom, remember I can't start counting until I get to my first non-zero number. So I start counting at the 6. The zeros before that will not count. However, since there's a decimal, the zeros after the 6 will count. So that gives us 2. Always pick the smallest, so our answer should have 2 significant figures in it. So I get 35.83 repeating. And we just said 2 sig figs. So 1, 2, look at the number next to it. That 35 is going to round up to become 36. That would be the answer there. Now let's look at number 9. So another calculation. We got 3 zeros and then 1870, 360. So for this one, we're going to multiply. We're going to do the correct amount of sig figs, and we're also going to put it in scientific notation. So we're doing it all. All right, and some of your calculators will spit it out in scientific for you, so that'll make your life easier. But we're going to practice doing it the old school way anyway. So we're multiplying. So what I'm doing here is counting sig figs as a whole. So that's the rule for multiplication. So I get 4 here, and I get 3 here. 3 is my smaller number, So when I multiply this out, I'm going to make sure to report it to 3 sig figs. If you see any mistakes in my calculations, please send me an email so I can put a correction on the video. I don't want people getting confused just because I pressed the wrong button in my calculator. So how many zeros do I got? 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 6, 7, 3. So I do have 3 sig figs already. Now I need to just put it in scientific notation. So when you do scientific, remember, move your decimal so that it has just one non-zero number to the left. So that's how I know it goes between the 6 and the 7. Then, to figure out the exponent, it's how many times you move the original decimal to get it to where the new decimal is. So that was 1, 2, 3, 4, 5, 6, 7. Since I moved to the right, and since the original number was less than 1, this is going to be a negative 7 exponent. All right, let's do the last one on the page, which is a density problem. So it's asking us to calculate the volume of 952 milligrams of copper wire. So hopefully you have the sheet in front of you, because I'm not going to write that problem on the board, but I will write the knowns and unknowns so we can keep track and figure out how to solve. So it's saying calculate the volume. So what that's telling me is volume's my unknown, volume's my question mark. Then it says of 952 milligrams. So milligrams, that is my hint to what that number stands for. Milligrams is a mass, just like grams is a mass, right? Just a different prefix. So I'm going to put that 952 with an M by it. And then it gives me the density of copper, which is 8.96 grams per centimeter cubed. All right, so when we're calculating density problems, we've used this density triangle if we need to rearrange, and that is DMV. Multiplication for the vertical lines, division for the horizontal lines. Okay, so we're solving for volume in this case. So if you're solving for volume, you're rearranging the original density equation. If you use the triangle to help you do that, you cover up the volume, because that's what we're trying to solve for. So we're going to take mass and divide it by the density. So my equation is going to be volume is equal to mass divided by density. Now, before I go plugging these numbers in, always double check your units. Okay? I have milligrams in my mass, but notice my density is grams. So these units need to match, because what I'm trying to do is cancel out those units, because I want volume, so I need to cancel out the mass. So I need them in the same units. So you can convert either one, your choice. It's usually easier to convert the mass just because it doesn't have multiple units going on like the density does. So my first step is going to be to convert my 952 milligrams, and I'm going to get it in grams. Notice, letter in common in the units. That's metric to metric. Okay, so you can either look up a conversion factor on your metric to metric conversion sheet, or see if the shortcut applies. Let's look. We have milli, that's this little m down here, and then we have grams. Well, notice there's not a G on here, but remember this empty space. So this empty space, what goes in there is the letter in common. So since G is the letter in common, G is going to go in that empty space. So this does apply. What I need to do to use it is to start at the little m, the milli, and go to the grams in the middle. So I'm going to start at the milli, go to the grams. So I'm going to have to move my decimal point, stopping at each one of these prefixes and counting that as one decimal place. So what that means is, move it once to get it to centi, 2 to get it to deci, 3 times to get it to the I moved it 3 times. Notice I went to the left. So that's what I'm going to do here. I'm going to start at the end of the number since there is no decimal point, and I'm going to move it 3 times to the left. So my grams is going to be point. That's where my decimal is on the other side of the 9 right now. It's 952 grams. So this value is the one I want to use in my calculation because I need it in grams so that the grams will cancel each other. So now that I have everything in the correct units, I'm going to plug it in. So my mass on top, so 9.952 grams. My density on the bottom, 8.96 grams per centimeter cubed. So notice grams cancel, they're on opposite sides of that horizontal line. So my units, when I'm done, are going to be centimeters cubed, because that's the only units left. Okay, so let's calculate this out and then write the correct sig figs, because we don't want to forget about those. 8.96. See, I'm already entering numbers incorrectly, so check my work for me, please, people. 0.10625. All right, so now we need to look at sig figs. You go back to the original numbers used in the problem and count the significant figures in each. Pick the smallest, because we're dividing. So 1, 2, 3. 1, 2, 3. Both have 3, so our answer should have 3. 1, 2, 3. Look at the number next to it. That's going to stay a 6. So our answer to the correct number of significant figures will be 0.106 centimeters cubed. All right, so that concludes the review question sheet. The exam is 36 questions and you have a 2-hour time limit. You only have 1 attempt. It'll open Friday and it'll close at midnight on Sunday. No makeup exams allowed, so plan your time now. Okay, have your equation sheets, everything ready. Since there's still time in class, what I'm going to do now is I'm going to go to the CHEM Exam 1 review packet. So this is the packet that starts with the definitions for those of you watching virtually so that you know what packet I'm looking at. And I'm going to skip all of the definitions and all of the sig figs rules and go to the conversions. So practicing more conversions. So it says be able to convert between American metric, metric American, and metric to metric. Okay, so I have 2 examples there. First one is going 55.2 quarts to gallons. The second is going from megagrams to decigrams. So since I already did 2 examples like that, I'm going to move down to number 3 so you can see one like that. Okay? So number 3, I haven't done an example like this in the review yet. I did do one during the conversion week, or conversion class, but we're going to take 75 miles per hour and we're going to convert it to kilometers per hour. So, say you're driving in the US and you're driving at 75 miles per hour. Okay, but you want to go up to Canada. Well, their cars and their speed limits are in kilometers per hour. So if you needed to do that conversion, this is how we would do that. All right, so let's look. I'm going to write this in a different way. This is 75 miles per hour. That means per 1 hour. Okay? And we're trying to get it to kilometers per 1 hour. Okay, so really our denominator is the same already. Hours, hours. So we don't need to do any conversions there. It's the top part we have to worry about. And the top part, we're going from miles to kilometers. So that's what I'm going to focus on, is going from miles to kilometers. So what type is it? Is it metric to metric or English to metric? No letter in common, English to metric. So you're going to go to your conversion sheet. We're measuring length or distance, so you'll look in the length area. Conversion factors, I do have one going from miles to kilometers. So I'm going to write that up here off to the side. It is 1.609 kilometers is equal to 1 mile. All right, so let's start our railroad tracks. We have all we need. It's just one conversion factor. It looks more difficult than it is, actually. So I'm going to start with my 75 miles per 1 hour. So this is my regular railroad track. Okay, notice the difference here is that now I have 2 units. So instead of just putting something in this upper left-hand corner, I need to put the hour portion in the bottom. Okay, so this is how it's going to look when I start. What I'm doing next is what I always do. I'm taking the conversion factor and I'm going to place it here. And I'm going to put it here to cancel out my miles and to keep kilometers. So I'm still going to put the miles down here so that the miles are on opposite sides of this horizontal line. I'm basically ignoring this for now. I'm keeping it there because we're going to need it at the end, but I'm not paying attention to it yet. So my miles are going to go on the bottom, so they cancel. That's going to put the kilometers on the top. Okay, so now notice the units that didn't cancel are my kilometers and my hours. And that's exactly what I want, kilometers and hours. Okay, so let's multiply this across. I get 75 times 1.609. I get 120.675 kilometers over 1 hour. So I just multiplied what was on top, multiplied what was on bottom. Okay, now let me look at sig figs. 2. So I want 2 here. So let's count. 1, 2. Look at the number next to it. That stays a 2. So my answer is 120 kilometers per hour. Notice I kept the 0 because I didn't want to go from 100 and something down to just 12. So I kept the 0 there. It's not significant, so I'm still at 2 sig figs and I'm still in the 100 range. All right. So next, let's continue on with the packet and look at number 4. So number 4, we have a gardener planting some flowers. The marigolds grow to 1.6 feet tall, the zinnias are 32 centimeters tall, and the begonias grow to be 18 inches tall. So what plant is going to be the tallest? Notice they're all in different units. So whenever you approach a question that's asking you which one's going to be the tallest, and it gives you several different measurements in several different units, what you need to do is get them all in one unit and then compare them. Okay? So pick whichever one you want. You can pick feet, centimeters, or inches. It really doesn't matter as long as in the end they're all in the same units. So I'm going to pick inches. So let's start with my begonias. My begonias are 18 inches tall. I'm going to leave them in inches, and then what I'm going to do is I'm going to take my marigolds, which are 1.6 feet tall, and I'm going to convert that to inches so I can compare. Then I'm also going to take my zinnias, which are 32 centimeters tall, and I'm going to convert that to inches as well. That way, I'll have all 3 flowers in inches, and I can compare the numbers directly. Because as it is, I can't compare because they're not in the same units. Okay, so it's 2 different conversions that I'm going to do. Once I'm done with those 2 conversions, I'll compare and pick which one is the tallest. So let's start with my marigolds. So we'll do this one first. What that means is I'm going to be taking 1.609 feet, and I'm going to go to inches. To do that, this is actually an English to English conversion. Feet to inches, right? So we still need a conversion factor. We still need to do the railroad track method. You can even use the memorized conversion factor. So how many inches are in 1 foot? 12. Okay, you probably learned that in grade school. It's coming back to you now. You have a ruler that's 12 inches and the ruler is 1 foot. Okay, so we're going to use this as our conversion factor. Once we have our conversion factor, we start our conversion, putting our original number that we need to convert in this upper left-hand corner, taking the conversion factor and placing it here to cancel out the feet and to keep the inches. So 1.6 times 12 gives me 19.2. So 19.2 inches. So I'm going to go over here to my marigolds. I'm going to erase this and put the inches so that I can compare. I'm going to put just 19 to keep with sig figs. Okay? It's not asking for the answer, so if you didn't keep sig figs, that's fine. But part of me has to keep the sig figs. So now looking at just comparing these two, the marigolds are winning. They're taller. Well, let's see about the zinnias. And I'll do the zinnias down here. So for the zinnias, we're going to take 32 centimeters and convert it to inches. Type of conversion, no letter in common, so it's metric to English. We have to look up a conversion factor. Doing this as long as I have, you have a lot of them memorized. So the one that you'll find that'll work is 2.54 centimeters is equal to 1 inch. Okay, so railroad tracks. Start with your 32 centimeters. Take your conversion factor, place the inches on top so that you can cancel out the centimeters, having them on opposite sides of that horizontal line. You can hear me say that all semester. In this case, we're dividing, right? 32 times 1 divided by 2.54. So let's see, 32 divided by 2.54, and I get 12.6 or 12.59. Which would round up, if I was doing sig figs, up to 13. Because I would need 2 sig figs. This is inches. So going back over here, my zinnias in inches are 13. So now, which plant's the tallest? Now that you have them all in the same units, compare the numbers. Whatever number is biggest, that plant's the tallest. And it is asking tallest, not smallest, right? Yes, tallest. So I unknowingly circled the marigold already, but marigold wins. 1 inch taller than the begonias. Okay, so your answer for that would be marigolds. What time we got here? All right, so now I'm going to move on and do a temperature conversion. So I'm flipping to the next page, since I haven't done temperature conversions in the review yet. Let's try one of those. And I'm going to do number 2 out of the 2 that you have in your packet, just because that's the harder of the 2. So we're going to go Fahrenheit to Kelvin. Now these temperature conversions, I did see in the discussion some people were concerned about memorizing these. Well, first of all, your exam, open note, open book. Also, even if you were taking it in person, we give you these conversions, these equations. Okay, so you would have them available to you. You wouldn't have to memorize them. If you look in your under course content, there is a link or a document that says all that you need. Go ahead, come on in. No one's here but this. So what you need to do is if you click on that, it's got all of the equations you need for chapters 1 through 9. All right, so converting 8.2 degrees Fahrenheit to Kelvin. So the equations that we have available to us, we can't get directly from Fahrenheit to Kelvin.
So what we need to do is go to Celsius first and then get to Kelvin. So if we're trying to get to degrees Celsius, we want to use the equation where degrees Celsius is equal to Fahrenheit minus 32 over 1.8. That way we can plug in this 8.2 right where the F is. Okay. So looking at that, we have 8.2 minus 32 divided by 1.8. 8.2 minus 32. And we're going to get a negative number, notice, because that number is smaller than that one, divided by 1.8. Negative 13.2. We want to keep it at 2 sig figs, so just negative 13. Well, I'll include the 2 just because we're not completely done yet. This is just our middle answer, right? So this is the degrees Celsius, but we still have one more step to get to Kelvin. So to solve for Kelvin, we're going to take our equation where you have the degrees Celsius and you add 273 to it. Now I believe in the PowerPoints I give you the 273.15. Okay, you actually don't need that 0.15. If you keep it, it's fine. It's not going to change your answer because once you round to the correct sig figs, that 0.15 is going to be obsolete anyway. So looking at this equation, we're going to plug in, make sure to keep the negative sign, bring that down. So negative 13.2, and we're going to add 273 to that. Plus 259.8. So I'm going to round that up to 260. So that is the temperature conversions. All right. So that about covers the review. There's 2 more density problems. Since I've already covered density with the original sheet, I'll leave those for you to do. I will post an answer key so that you can practice them and check your answers. And I believe these density problems, we already did number 2 in class on a video. So you already have seen me work that one. I think I put it down there again. But all right.